Hello everyone. In this video I'm going to share about the resonance. So we will learn the resonance by taking ozone O3 molecules. Okay. Now first of all, in order to start the resonance concept, we have to know about the Lewis structure. So the Lewis structure of the O3 is oxygen. Okay, oxygen with double bonded and one oxygen with single bonded. Okay, so oxygen with double bonded, this double bonded will always have two lone pair, and oxygen with single bond will have three lone pair and with negative sign. And this oxygen with 1, 2, 3 bond will have one lone pair and plus charge. Okay, so this is the Lewis structure of O3 molecule. Now this lone pair, okay, so this lone pair can be changes into pi bond. So I will just transfer this lone pair here. Okay, and now this oxygen, okay, this oxygen now will change into pi bond. Okay, initially there was how much lone pair? 1, 2, how many lone pair? 1, 2, 3, 1 lone pair, 2 lone pair, 3 lone pair. 1 lone pair has transferred here, means how many lone pair remaining? 1 lone pair is 2 lone pair is remaining here. 2 lone pair, 1 has already gone, so 2 lone pair. Now another pi bond is here, but if I draw the pi bond here, the compound will be very unstable because this oxygen will have how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So oxygen with 10 electrons will be so unstable. So to stabilize itself, okay, this pi bond will start shifting here. Okay, so there is this lone pair and positive sign. Now this pi bond has shifted towards this oxygen, okay, and a single bond contain 2 electrons. Okay, so initially there is how many lone pair? 2 lone pair, and this pi bond has shifted, so it will be another lone pair. So oxygen with 3 lone pair is always negative sign. Okay, now this two structure which we can draw either in this form or in this form. This let us represent it by structure 1 and let us represent it by structure 2. So we can represent in either of these two structure. So these structures are called canonical, is called canonical structure. Okay, so let us see here what happened overall. If we see here shifting of pi bond is taking place. Initially there was single bond and it has changes into pi bond. That means this pi bond has transferred here. So here shifting of the pi bond is taking place. So this two structure is called canonical structure, and from this two structure we can draw in the form of another structure, or we can call it as this is resonating structure. Okay, now the real structure or the hybridized structure can be drawn in this form. So oxygen, since the pi bond is transferring from here to here, so we can represent it by this line because they are not fixed. Sometimes they may remain here, sometimes they may remain here. So this is delocalized. This shows the delocalization of the pi electron. This is called the hybrid, or this is called the resonance hybrid. Okay, so among these three structure, this is the stable structure and they will always try to remain in this form. Okay, so among this canonical structure, between this canonical structure always there will be double-headed arrow. Okay, and shifting of the pi bond takes place. Okay, so in this way we have shown here, and this is called your canonical structure and this is called your resonance hybrid. So what is resonance? Resonance means where a single Lewis structure cannot explain all the properties of the compound or molecule. So we have to represent it by 2 or more Lewis structure. So this is called, which is representing by 2 or more structure, is called resonance.